Now, a couple of days ago, Linus Tech Tips put out a video about home energy storage, and I'm kind of surprised to have seen this on their channel. You see, they used Tesla Model S modules from the battery pack and connected that with an inverter. Now, this isn't the first time these things have been done, and it kind of felt, with my name being Battery Man, to let's pick this to pieces. Now, I'm not here to slate or pick out all the things that they have done wrong, but have spotted something which may make a huge difference to their project in the future. Let's get watching Linus Techie Tips and see what we can find. Now, if you've not seen my videos before, I'm the guy in the UK who sticks Tesla Model 3 batteries on his house for home energy storage. Now, that might come in a little bit later with my suggestion. Linus has messed with batteries and 18650s before. Now, Linus has done what every parent should do in the past on his videos and upgraded his kids' electric cars to a more powerful pack with 18650s. And he's also had the old Sparky. So, what on earth is going on with this install that he's done? Now, if we're just going to touch on safety for a minute, 48 volts can, in the right circumstances, kill a person. So I don't think that we should look at this like 48 volts is safe and anything I'm going to suggest later on is not safe. Just bear that in mind. I know for a fact, based on my own videos, that what you see sometimes isn't the finished product and there's extra safety things and things are being considered. So let's have a look.
I've spent the last several years remodeling my home into a techie's dream, with gaming PCs, 10 gig networking, and screens everywhere. And it's kind of awesome, but there is one fatal flaw. Despite the solar panels we installed on the roof providing some clean energy some of the time, the system was designed to feed excess power back into the grid rather than into a battery bank.
This is the thing, battery banks are fantastic for being able to store the cheap or practically free electricity that you generate on your own roof, but there's more to it than that for Linus.
So, during the stormy season, we regularly lose the one thing a techie house needs more than anything else. Come on! The power!
Now, I'm just chuckling to myself because there is somebody behind that camera with a remote who's either turned that telly off or that monitor, or he's pressed the power off. So, knowing what goes on behind the scenes in filming videos, that just makes me chuckle. But he has a point. So, if he's in an area with power outages, imagine losing the power to all of his devices, his servers relying on his UPS and not being able to cook, shower, shave, all of those things. That could be really annoying. But the solution that he created later on, I actually don't think is big enough for his whole house and to cover those scenarios. I wonder how long those outages are.
So it's time to solve this once and for all with a proper home power backup.
Look at Jake there. He looks excited and also a little bit scared to show Linus what he's just made.
Jake, this is not what we talked about.
What do you mean? It's mint. I thought
Oh, that's hilarious.
Yeah, of course I want something cheap, but I want...
Got him. You see, Linus isn't the only one who's tired of our crappy power grid. And when I heard him complaining about it, it gave me a wonderful idea.
I absolutely love these janky setups that actually work. We've seen that with Linus. It's those sort of videos. I'm not so much about the tech product reviews, although those are great as well. But the janky setups, they have me in stitches. And believe it or not, I don't think this is as unsafe as people in the comments would have you think. I went to the comments and no surprise, there are so many comments about this being unsafe and all the jokes that go with that. But people know the jankiness is not always the way it is with these things with Linus Tech Tips. But there's definitely some improvements. But as I said, the focus of this video isn't to tear down what they've done. It's to offer some improvements. Now, since we're looking at this, the thing that scares me is that those batteries are not that high off the ground, and he had leaks in there in the past, and this is a room which he's obviously got all his plumbing in. If the power goes out and he's got some sort of sump pump in there, then it's not going to work. I don't really know how it's set up, but you do not want those packs covered in water. They will get damaged at minimum. or potentially cause more problems. But yeah, this is the thing. This is basically, Jake has proposed this, hasn't he? And just suggested that he does something that he wants to have a play with. I would love to spend Linus's money and learn and play with some of the stuff that we get to play with doing these things. So pretty envious of Jake right now. I'm also pretty envious of Linus Tech Tips with this video because it's had well over 1 million views by now. Crazy. But the most sketchy videos do well, hey?
Specifically, these 4 battery modules we picked up from a scrapped Tesla Model S battery. They were $250 a pack.
Here we go. So Tesla Model S cells. I reckon that the cells here are pre-2016. Now, later on, we've got a clip here, and he shows them with the BMS board that's on them. And that BMS board is the revision A, which is the earlier ones, which means these cells are going to be older and even more slightly less suitable for home energy storage. Now, spot here, these boards show 4 millivolts of imbalance. Now that is good. So that also tells me that somebody has quality controlled these modules before they've either sent them to Linus Tech Tips or somebody at Linus Tech Tips. Bearing in mind we've got electrical engineers there. Somebody has looked at these packs and they've worked out what the condition of them is. And does that say okay under it? Now what I would like to have seen, and I would have thought they would have done it, but I'm surprised given all the other information they put in this video that they haven't shown it. But I would like to see how many amp hours each of these packs had. If they compared them all and then they need to balance them all and put them in so that they are all roughly equal. Now, there's every chance that where they've brought them from, they've all come from the same vehicle, which would mean that they are probably going to be really well balanced. If they've all got that OK symbol, then they're all going to be pretty similar. But that is nice to see, and that is a good move. Now, people have been using these things for home energy storage for ages. Even, you know, they've been out for years, but people have kind of moved on. And the way we do things now, entire pack. In comes the battery emulator. Now, I've put over 120 kilowatt hours of EV batteries on my property using a complete EV pack, LFP, just like he mentions, and that is then able to run my entire home. I've not actually set that up for backup power like they have because I don't have that issue here. Power is pretty reliable where I am. Now, I don't think I've seen anywhere in this video the little orange covers that go on top. Even though each of those packs is only 24 volts and there's 48 volts in total, I would like to see the little covers. Maybe they don't fit with the cable lugs that they're using, but you want to cover that up, really. They could probably 3D print something. Okay, EG4, I don't really know much about them, but as far as I'm aware, they're pretty decent inverters. These sort of inverters, they tend to be quite noisy. They don't have massive heat sinks, so they rely on a lot of air passing through them, especially when they ramp up. More commercial on-grid systems tend to have massive big aluminium heat sinks to be able to soak up some heat. Yeah, this inverter is designed for a completely off-grid setup, isn't it? It's designed for somebody that lives in the woods. Yeah, so he's talking about big grand schemes of powering the whole house, which is exactly what the battery emulator is for. It's for providing enough battery storage in a safe way with an entire EV pack, using the vehicle's BMS, using the vehicle's contactors, using the vehicle's fuses, in a system that's completely combined, and all you do is connect to the high voltage terminals on the outside. So actually, I think that compared to a setup like this, a properly set up battery emulator EV setup is actually safer and will probably suit what he mentions at the end in wanting to go to 200 kilowatt hours, which is doable.
Kinda awesome.
Not that crazy, right?
Now all we need to do is 10x it.
Yeah, a 200 kilowatt hour battery would be freaking sick. But where do we put it?
But at that stage, I wouldn't be putting this inside that room. I would be sticking it outside, yeah. That's the thing. How much information do you share with your audience? Because no doubt there's a lot of knowledge here that or a lot of research that he's done. but it's how much do you share with the audience, hey, to make a fun video, which Linus Tech Tips are good at doing, let's face it. Now, I watched this the first time, and I was looking at that, the battery inputs, and there's no glands there. Now, I'm pretty sure later on in there, they do have glands. But this is the process you go through. You create yourself a little rig to mimic it and make it work. Now, here in the UK, you'd want to see isolators on there as well. If you need to do anything on that inverter, how are you going to make it safe if it doesn't have a rotary isolator, which is capable of handling the load, as well as the fuses to disconnect that inverter? Maybe they're relying on disconnecting the BMS and there not being power, but yeah, I'd like to see isolators. Now, that's another thing with EV packs. EV packs come with contactors on the positive and negative side. They also do a load of insulation resistance tests to make sure that there's no power going to ground. So, way safer than a contactor just on a bench.
How do you know?
Okay, so this is where my major issue is.
The Vero Electric BMS V2. This thing is the brains of our operations, or at least of the battery side. This thing allows...
Now, if you look up this BMS, it's been designed by somebody to work with the slave BMS boards on the Tesla Model S packs. Great, and as a product, I'm sure it's great. I've not heard of it, but look how much it is. It's nearly $1,000, and then you start adding on the CT clamps and other things that you need to make it work. Oh, and that little display monitor that fell on Linus.
Considering it can do 6 kilowatts. Yeah, I didn't. I was just chilling there.
That's confidence inspiring.
Then you're starting to get really expensive. Now, the option that I mentioned includes a free BMS. If you buy an EV pack, and surprisingly, they're not as expensive as you think, a couple of $1,000 potentially if you wait around for the right bargain. They all come with an inbuilt BMS and potentially other controls as well. So yeah, I understand why they've done it, but they've massively increased the cost per kilowatt of the whole system by using this BMS, and good on them for using a BMS. Now, this bit here is something that I didn't quite get. Maybe it's a Canada thing, but that plug he was holding up, in the UK, you cannot have something that can give power out and have all the pokey bits accessible. What if that inverter was running off battery and then it was changed to switch to grid and that plug was out? You could touch 240 or 120 volts AC with a device that doesn't have residual current protection behind it, if that means anything to the people watching. Yeah, that's not how we do it here. 120 volts AC. Rubbish. Yeah, I don't like that at all. You are feeding power back through a plug which you could touch if it was disconnected. Now that's the biggest thing that I just do not like here. But as I say, it's not. The system is great. It's fun. Aren't Canadian and American houses made of combustible wood? Well, we're at the combustible wood thing. I would like to see this entire rig on some sort of cement board or fireproof board to go on that wall. It's just how we do things here to keep things nice and safe. I just want to walk around that room and point to things and go, what is that? What is that? Look, things are only cheaper if you really know what you're doing. If you've got the skills and the abilities, you're going to have taken time to do that. So your time is worth something, and ultimately that's an entire battery in a box, can be mounted on a rack. Yes, it comes with more cost, but it has everything.
It's very important that you get wire that is thick enough to handle the amperage and the amount of energy that you're passing through it. And this 6,000-ish watt inverter means at 48 volts, peak load, 125 amps. That's a lot of freaking amps, man.
It's a lot of current, and it shows the limit of 48 volts. This is why I think that high voltage inverters using batteries from Tesla Model 3s, all of the EV batteries, but LFP. That is why it's such a good idea. My systems are passing a massive amount of power, 5 times more than this, and I only move 50 amps per battery, which is a lot less, which means my cabling is a lot smaller. It makes me chuckle they're challenging getting the cable. It just shows they don't go down to their electrical wholesaler that often. Like somebody going to a car parts store and asking for blinker fluid. Linus just looking at that cable thinking, is this right?
Hey. And then this is just batteries out of what? A Model S?
Yes.
What'd we pay for them?
Very little. For the uninitiated, this is 20,000 watts for an hour.
Or
that seriously is
1,000 watts for
the
20
major part
hours.
that I would change.
Assuming no losses and whatnot, we're just perfect world. Anyways, and it was $1,000 Canadian, which
what?
Americans is like 600 US.
Dude,
that is 5 kilowatt hours and is $2,000 for the big deployment. We're probably not gonna...
Yeah, so as I mentioned previously, these are most likely being revision A from a pre-2016 vehicle. I'm sure they'll know, I don't know, but that means that they're going to have some degradation. At minimum 10%, but possibly more depending on the condition of the vehicle and literally how old they are. The older the battery gets, the more it naturally degrades anyway. That's a pretty decent price that they've paid for those, and I tried to work out the cost difference with my battery, and that's pretty comparable, but that doesn't work out comparable when you include the price of that BMS. That dramatically increases the price, and EV batteries win. They were so close with it, weren't they? Talking about the entire pack and how much there was in there, but they just haven't thought of the option. Now, how on earth did this work? So the Battery Emulator project converts the CAN bus data of a vehicle BMS to the CAN bus data of a inverter that handles 200 to 800 volts. It's as simple as that. A CAN bridge that mimics the communication and allows the BMS to do its job to keep things safe and the inverter to do its job. Now, that is a piece of software that runs on an AliExpress CAN board called the Liligo, which is about $5. Seriously, it's that cheap. With a bit of wiring, the whole project is super cheap to run. It's on GitHub, it's open source, and the community is always trying to add new batteries and improve it. Basically finding out the CAN bus data of vehicles and inverters and then mimicking that to make these things work. So if he had put, I don't think the Model S is supported, but if he'd put a Model Y or Model 3 battery, and there's LFP options there, in its place, you could get that for a few $1,000s. You wouldn't need to buy an additional BMS. You'd have a little board which you can then connect up. And I know that Linus uses Home Assistant, and through MQTT, you can connect up the Battery Emulator to Home Assistant and read the data on it as well and monitor it and then act based on what that pack is doing. You might want to force charge. And of course, because it actually works with the inverter quite often can connect up to Home Assistant and reports all that data too.
Battery management it can talk to.
So we could set the charge current to whatever we want if we wanted to control temperatures or...
Yeah, 100%. So actually, in a Tesla, I mean, if you look, there's coolant terminals on the outside.
Yeah.
And you can water cool them. And realistically, if you're doing an EV conversion, you really would want to water cool them.
But we could hook it up to the pool.
Yeah.
Okay, so water cooling is probably a complete waste of time. You probably... what is the temperature? Hey Siri, 26 to 29 degrees. That's colder than I thought. I thought it was going to be more like 30. So, 26 degrees... That's an okay temperature to keep the batteries, but I think it's a complete waste of time for them for what they're doing. But I don't know, they are pulling potentially 60 amps. It really does depend on how hard they work, these batteries. The more batteries they have, the less it's going to be an issue. And yeah, you generally don't need it in home energy storage applications. Okay, so with that, 29, let's say 3,000 watts, and we're going to divide that by 48. So that's 62 amps. That's 30 amps off each one. I mean, they may well warm up a little bit, so yeah. Be interesting to see what they do there with the temperatures. Well, there we go. If you haven't seen my channel before, I put batteries on my house. I mess with electric vehicles. I mess with heat pumps. It's basically all things techie, but kind of electrically focused, engineering-y sort of stuff. And yeah, I've got a whole collection of videos. Why don't you like and subscribe? Look out for future videos. And thank you for watching, guys.
Or we could just segue to our sponsor.
Well, why don't I segue into my sponsor at this point? This video is entirely sponsored by myself. That's right. If you haven't seen my channel before, please like and subscribe. Drop a comment. Tell me what you think of Linus's install. And tell me what you think of the option of putting EV batteries. Does that seem less janky to you than using those batteries that they've used there? Let me know in the comments, but above all, thank you for watching, guys. See ya.